Here we are in section 7.3 where we are dealing with ellipses. You may call them ovals, but they are really officially called ellipses. Now the nice thing about ellipses is that the equation, in order for us to work with it, really needs to equal 1. So if we don't have something equal to 1, then we need to make sure that we get it there. So with that in mind, let's look at what we have here. 4x squared plus 49y squared is equal to 196. And what we need to have this equal to 1. Now how we're going to do that is we're going to divide through everything by 196. So if we divide this by 196, divide this by 196, and 196 divided by 196 is 1. Now what we're going to do is we're going to simplify this even further. 4 over 196 equals x squared over 49, and 49y squared over 196 is y squared over 4 equals 1. Now this tells us quite a bit. First of all, what we look at is we need to determine which of these two denominators is the bigger one, and in this case it's this one. The bigger number always gets the a. This is a and this is b. But actually it's not a, it's actually a squared. A squared equals 49 and b squared equals 4. But we want to know what are a and b. So a would equal 7 and b would equal 2. Now normally we would have to take both the positive and the negative, but a and b in this case, or in these cases, represent the distance, and so it doesn't really make sense to have a negative 7 for the distance. Now what we are asked to do is find the foci and the vertices. Now realize on an ellipse what happens is this. An ellipse has two vertices, there and there, and they're on what is called the major axis, or the longer axis. The shorter axis is called the minor axis, and there are points here, but those aren't called vertices. The vertices occur on the major axis, the elongated part of the ellipse, so to speak. And then there are foci. There are two focuses, if you want, or if you will. And realize we have values that we're going to have to calculate and determine in each one of these cases. So the first thing is we want to find what are the vertices. Now the vertices are relatively simple. First of all, just like last section, if this doesn't have x plus 3 in parentheses or y minus 5 or something like that inside parentheses, then the vertex will be right, or not the vertex, the center will be at 0, 0. And that makes life a whole lot easier. But now we need to determine what are the vertices. Well, that's where A and B come in. A deals with the major axis, so from the center out to the vertex will represent A. So we get A. So one of the vertex would be at negative 7, 0. And the other one's going to go over here to the right, so that would be at the point 7, 0. Now how do we determine the foci? Now the foci we need to first of all determine what is C. We have to determine what C is. Now once we get A and B, we can use this fact. B squared equals A squared minus C squared. It's somewhat similar to the Pythagorean theorem, but this is how we determine what C is. B squared equals A squared minus C squared. Okay? So we would get 4 squared equals 7 squared minus C squared. Or C squared would equal whatever negative C squared would equal whatever 16 minus 49 is. So negative c squared is going to equal what? Negative, that's 33. And so c squared will equal 33, or c, because that represents a distance also, will equal the square root of 33. And where did I go wrong? I don't think I have. So now realize what happens is this c represents the distance from the center. And so this would be, the one focus would be on the left side of that, so that would be negative root 33, 0. And the other one would be positive root 33, 0. Okay, and so that's where the foci would go. So this is just short, a little bit shy of negative 6 and a little bit shy of positive 6. And so there would be the foci and the vertices that are requested. Number 2. Number 2, we're told the center is at 0, 0. Oh, that's good. The focus, we have one focus at negative 3, 0. That's going to be here. So we immediately know the other focus is going to be at 3, 0. And there's a vertex at 8, 0, way out here. And so we would immediately know there's another focus out here at negative 8, 0. So got potentially a pretty long ellipse going on here. So let's figure out some of the values that we have. We know that c is equal to 3 because the distance from the center to the focus is 3. We know that if the major axis A is equal to 8 because that's the long axis, or the vertex to the center has a distance of 8, so that's A. And so then we need to be able to calculate what B is. Well, B squared equals A squared minus C squared. This is the relationship we need to remember. So B squared would equal 8 squared is 64, C squared is 9, 64 minus 9 is 55. And so B would equal the square root of 55. So now we are asked to find the equation of this ellipse. Well, the equation of an ellipse always looks like this. Equals 1. We always put, since x, the major axis is on x, that goes here, so it's going to be x squared over something, y squared over something. The major axis is a, so that would be not 8, but 8 squared. And the minor axis, or the other one, is the distance for b, so that would be the square root of 55 squared. Cleaning this up, we get x squared over 64 plus y squared over 55 equals 1. And this is the equation of the ellipse with the center at 0, 0, focus at negative 3, 0, and the vertex at 8. Number 3. Number 3, we have a focus at negative 6, 0, and the vertex is at both positive and negative 7. So that tells us that it is centered at the origin, which is really nice because we would need to know that on both of those. So that means there's also a focus over here. So just filling in some information, we know that A equals 7. C would equal 6. And B, which actually tells us the lengths of the minor axis, You know, this would go up by whatever b is, and this would be going up wherever b is. Keep that in mind when we actually need to graph these. But we still need to remember that b squared is equal to a squared minus c squared. So in this case, we know that a is equal to 7. So 7 squared is 49. C in this case is 6. So 6 squared will be 36. And so this equals 13. So that means b equals the square root of 13. So now we have, as long as we have a and b, we can find the equation. So that will be this form. It always equals 1. The major axis is on the x, so it's going to be x squared and y squared. A goes with the major axis, so a was 7. 7 squared is 49. And b goes with the minor axis, or the y. And so square root of 13 squared is 13. So final answer is x squared over 49 plus y squared over 13 equals 1. Example number 4 will finish up this particular group of problems, but let's see what we have here. Number 4. We have center of 0, 0. Okay, nice to have center of 0, 0. Major axis is horizontal with length of 18. So that means from here to here is length of 18. So that means this would be 9 and 9. Or in other words, A is equal to 9. The length of the minor axis is 6. So that means from here to here is 6. So that means this distance here would be 3. Or B. This is B. Now, the rules still apply. We know A is equal to 9, B is equal to 3, and that's all we need to do in order to get the equation of the line. We know that since the major axis is along the x, then that means x squared gets a squared, and y squared gets b squared. So a squared will be 81, b squared will be 9, and so there's the final answer. X squared over 81 plus y squared over 9 equals 1. Number 5, or example number 5, asks us to graph the ellipse and to locate the foci, or the foci. And so here we go. We have 4x squared plus 9y squared equals 36. Well, in order to do anything, we need to get this to be a 1. So we need to divide everything through by 36. So this will be x squared over 9 plus y squared over 4 equals 1. Now I know since this is the biggest, that means a is equal to 3, and perhaps more importantly, a equals 3 goes along with the x-axis, and here b would equal 2. Now we know that, what relationship do we know? We know b squared equals a squared minus c squared. So 4 equals 9 minus c squared. Or solving for c squared, we get negative 5 equals negative c squared. C squared equals 5, so c will equal the square root of 5. So we need to graph the ellipse. We know the major axis goes out 3 for the vertex in both directions. The minor axis is going to be 2, because that's what B represents. And C, the focus, will be at root 5, which is slightly above 4 and slightly below negative 2. So, and then we try and draw a fairly nice ellipse around there, and we get something that looks like that, and realize the focus here would be negative root 5, 0, and the focus here would be square root of 5, 0 on the positive end. Going on, example number 6. Example number 6, let's see, we have 3x squared plus 5y squared minus 36x plus 30y plus 138 equals 0. Okay, now, first off, this is not going to be centered at the origin because we have x values and y values. We don't just have x squareds and y squareds. So the first thing we have to do is group all of our x's together. So we're going to get 3x squared minus 36x. And I'm going to leave, well, not quite. And then I'm going to group all my y's together. So that'll be 5y squared plus 30y. And then I'm going to bring the 138 over to the other side. Now eventually we need to get this to be a 1, but we'll deal with that in a second. Okay, now, in order to complete the square, I need to get rid of this 3 here, so I'm going to have to do that by factoring out the 3. When I factor out 3, out of just the x's, I get x squared minus 12x. And now I can actually complete the square here. So take half of this is 6, and square that, I get plus 36. But it's also important to realize I did not just add in 36. What I added in was 36 times 3, which is 108. So I've actually added in 108. So to compensate, I'm going to have to come over here and add in 108 on this side. Okay, so that's my first step. Then I need to do the same thing for the y's. The y's, I need to pull out that 5. That's going to leave y squared plus 6y, and I can complete this square. Take half of 6 is 3, square that, and I get plus 9. But I didn't just add in 9, I added in 5 times 9, which is another 45. And so when I look at this, negative 138 plus 108 plus 45 ends up being, what, 15, I believe? So I've got 15 there. Now I need to rewrite this, so I get 3 times x minus 6, the quantity squared, plus 5 times y plus 3, the quantity squared, equals 15. Now I can finally try and get this to become a 1 by dividing everything through by 15. Dividing this by 15, we get x minus 6, the quantity squared, over 5. And this becomes y plus 3, the quantity squared, over 3, equals 1. Now we should be able to do some stuff. First thing we need to do is find the center. Well, the center is going to follow the same rules as our parabola from last section. Basically, we should be able to look at this and say, oh, I know what the center is. Well, the center will be, just like in the parabola, x minus the x value, so this would be 6, y minus the y value, so that has to be negative 3, so the center is at 6, negative 3. Now here's where we need to do potentially a little bit more thinking, because it's not quite so simple anymore. And what I'm going to do is I'm just going to draw a rough sketch. 6, negative 3, you know, is somewhere over here. Okay, and I know the ellipse is going to go like that. Okay, what else do we need to find? We need to find the foci. Okay, so that means since this is the biggest, that means the major axis goes this way. So our major axis is going to go along this way. How far away from this point, from the center? It's going to go, well, I need to find what C is. Because I know that b squared is this. No, I'm sorry, a squared is 5, b squared is 3. So I need to come back up here and say, okay, b squared equals a squared minus c squared. B squared is 3, a squared is 5, minus c squared, and so c squared would equal, or negative c squared would equal negative 2, so c squared would equal 2, so the square root of 2. So I have to go square root of 2 this way, square root of 2 this way. Now this is where it's not quite so simple, because what we have to do, these are the foci. The foci would be, okay, I'm here at 6 and I'm going to add square root of 2, right? So I'm going to, my focus will be at 6 plus root 2, but it's still going to be at negative 3. And then it's also going to go, start here, but go back root 2, so it's going to be 6 minus root 2. Negative 3. And so there's the foci. And then finally the vertices. The vertices are going to go from the center, they're going to go a away. Well, a squared is 5, so a would equal the square root of 5. So I need to go square root of 5 beyond this point in this direction, and then coming back this way. So if I add 5 here, need just a little bit more room. So the vertices would be 6 plus root 5 and negative 3, and 6 minus root 5 and negative 3. And notice I'm just sending them just beyond the foci there. And so that is the final answer for number 6. We found the center, the foci, and the vertices. Number 7 asks us to graph the equation, or graph the ellipse. So as we do that, we need to go through the whole process. We need to figure out all the important stuff and then start putting things in. So number 7 is 4 times x minus 2 quantity squared plus 9 times the quantity y plus 2 quantity squared equals 36. First thing we have to do is get this equal to 1. So I'm going to divide everything through by 36. This is going to become x minus 2, the quantity squared, over 9. And dividing this by 36, we get y plus 2, the quantity squared, over 4 equals 1. So a will equal 3, because this is actually a squared. This is the big one. B is equal to 2, because this is actually b squared. That tells me quite a bit as far as how to graph it. First thing we need to do, well actually this is all we need, because I need A to graph an ellipse. I need to know A, I need to know B, and I need to know the center. So the only thing left is the center. Well, the center here, x minus the x value, so x minus 2, and y plus 2 means the y value is negative 2. So I am now ready to graph it because I have A, B, and I know the center. So the center is at 2, negative 2. Right at that point right there. I know this is an ellipse that goes, the major axis is horizontal. So there's my major axis. How far away is it? Well, A. It's 3 away from my center. So that means I'm going to have to go 3 to the right. I'm going to have to go 3 to the left. And there's my vertices. And then to find how high does it go and below, it goes 2 above the center and 2 below the center. So it's going to be there and there. So I just need to make sure it goes through those points and try and make this look as good as possible, which sometimes is a little more difficult than it seems. But there we get our ellipse with the necessary work to justify that our graph is indeed correct. Example number 8. Okay, got lots of information. We are find the equation and graph it. Well, I think by helping or by graphing, it might actually help a little bit. So let's see. Vertices are at 5, negative 4. And 5, 8. Okay, now this is the first that we've had in these notes. Now our major axis is going this one. So since it's going that way, that means A, the big one, goes to the y value, because this is a vertical major axis. So we know our final equation is going to be x squared over something plus y squared over something equals 1, but the big number is going to go down here because the major axis is going there. Now the first thing we have to do, oh, I've already messed up, because what I need to do is first of all determine what is the center. Well, the center between 5, -4 and 5, 8, and you can find the midpoint of this using the midpoint formula pretty quickly, would be 5, 2. So the center is at 5, 2. That's the first thing we need to do, and that's what messes this whole thing up down here. So I need to get rid of this, and we'll try it correctly this time. Since I know my center is 5, 2, it's going to be x minus 5, the quantity squared, over something, plus y minus 2, the quantity squared, over something, equals 1. Now, in order to find the equation, all we need to do is figure out what is A and what is B. We're also told the length of the minor axis is 6. So from here, we're going to have to go 3 to the right and 3 to the left. And so what our graph is going to look like, we can immediately graph it now. So I'm going to try my best, although I missed that entirely. There, it's a little bit better. And so this is the way the graph is going to look, but now we just need to finish this up. We need to realize that this is A, and this represents the length of 6. Now, since it's going vertically like this has to be A squared down here. So A squared here, 6 squared would be 36. The minor axis is going this way this time, and this distance from here to here is 3, because we know the total distance is 6, so this B, this has to be B squared, 3 squared is 9. And so there is the equation, x minus 5 quantity squared over 9 plus y minus 2 quantity squared over 36 equals 1. And here is, if you ignore this, I don't want to erase it, otherwise I'll lose my whole circle. But this is a relatively decent attempt at an ellipse. And finally, problem number 9. Number 9, the orbit of a planet. Okay, so, and hopefully we realize that orbits are ellipses, and the sun is at one focus. Okay, the aphelion is the greatest distance from the sun, so the aphelion is from here to here. Okay, the perihelion is the closest distance from here to here. Okay, so the aphelion is the farthest distance, the perihelion is the shortest distance. Now it says the mean distance is the length of the semi-major axis. Okay, so the mean distance is from the center to, or the semi-major, oh wait, semi-major. Whoops, this is minor. Work back, I need to go backwards a little bit. That's the semi-minor. Semi-major is half of the major distance. So that would represent the mean distance. So a planet has a perihelion, so that's from here to here. Perihelion, remember, is from the focus to the closest, or from the sun to the closest place that the orbit takes it, is 550.2 million miles. The mean distance is 552 million miles. Write an equation of the orbit of the planet around the sun. Okay. First off, I'm going to make it real easy. I'm going to center this at the origin. Okay. So I've taken care of one small headache. Okay. So now what we need to do is we need to determine some values. Since we're centered at the center, it's going to be x squared over something plus y squared over something equals 1. Know that much right there. Now all we have to do is find a and b. Well, we need to find the distance from here to here. Well, to find a, distance from here to here is 552. So this would be 552 squared. And we know it goes with the x because I made x be my major axis. Now what we have to do is we have to figure out, okay, what does y squared? Well, we know that from the focus to the um, vertex is 550.2 million miles. But from the center to the vertex is 552 million. So that would mean that the distance between there and there, which we always call c because that's the distance um, between the oh wow, I'm losing it. The distance between the center and the focus is always c, and that's how we would determine it. And we have to remember this is the relationship, b squared equals a squared minus c squared. Well, we don't know what b squared is. If we did, we would just put it in here and we'd be done. We would be done, won't have to worry about it. So that's what we're trying to find. B squared is equal to, well, we know a squared is equal to 552 squared minus, and c squared, well, c is the distance from here to here. Well, that doesn't take too much. If it's 552 from the center out to here, and between here and here it's 550.2, then that means c has a value of 1.8 million, or 1.8 squared. So b squared will equal, okay, 552 squared. Oh boy. Let me get my calculator out here real quick. I knew this would be coming up. Okay, I need 552. Square that. So that is 304,704 minus 1.8 squared. It's 3.24. Wow. And so b squared would equal whatever those two are subtracted. So that would be what? 304, 704. 304,700.76. So that's what goes here, 304,700.76. And of course 552 squared is already 304,704. And so the final answer is x squared over 304,704 plus y squared over 304,700.76 equals 1. And that is the answer for number 9.